Hello, physicists, and welcome. On this session, we'll be looking at the first example in the series and parallel practice sheet. Let's get started. Hey, so you'll see on these we have a scenario, schematic diagram. There's this voltage graph. I'll describe that in just a little bit. Our table of values here indicating our voltage, current, resistance, and the power in the circuit, and then a workspace here. What I've done a little bit ahead of time, I've ordered our position, starting with 0 at the negative or low voltage end of the battery, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then back to 0 to complete the circuit, identifying each of these little circles where we'll place voltage. You'll see this. It says, fill in each circle with the appropriate voltage at that point. Note equal brightness bulb. That's going to give us important information. Hey, so let's go and get started. Schematic diagram. Okay, so I have a battery. I'll draw my symbol for a battery. I have wires around to a light bulb. Wire to a light bulb. And then I have a wire goes to my next light bulb. And then back around to the battery. Complete this. I'll put value here and a value here. Hey, so we see some other information. We have equal brightness bulbs. So what's that going to tell us? That should tell us that the voltage drop or the voltage released at each of those is going to be the same. So R1 is going to be equal to R2. Also, it's a series circuit, so we're going to have the same current all the way through. Let's go and fill in that. We're going to have the same current. Whatever leaves the battery goes through through the resistor, known as a light bulb, through the light bulb and back here. So I'm just going to put a couple items here. Put my units for each of these to save myself a little bit of time, and then power, of course, is in watts. Hey, so let's go fill in things that we know. Hey, our current is going to be the same throughout, so 0.45 and 0.45. Hey, in a in a circuit, we know that the resistance of the circuit is going to be equal to, in this case, R1 plus R2. And we know that R1 and R2 are equal to each other, so the resistance of the circuit is going to be 2 times R1. Let's figure out what that series circuit is, or the series resistance. R series is going to be equal to our voltage divided by our current. Voltage is 9 volts. Current is 0.45 amps. Tells me it's 20 ohms. So my overall resistance is 20 ohms. I know that R1 is going to be my series resistance divided by 2. So 10 ohms. The other one must be 10 ohms. All right. Hey, with that, it looks like I can figure out some voltages. V equals IR in all cases. Let's see. My current is 0.45 amps times 10 ohms, that's 4.5 and 4.5. Let's go and check and make sure that solves our requirement. In a series circuit, our voltage is increased or raised by the battery, and it drops across the light bulbs. And it was raised 9 volts, and it drops 4.5, drops another 4.5. Altogether, we have 9 volts here. Yep, it checks. All right, good. And our power is equal to our current times our voltage. Let's do this. Okay, 9 times 0.45. Put that in my calculator. I get 4.05 watts. I'll do the same thing for my other two. So that's the power going into the circuit, power being used by the circuit. A resistor uses that power. 4.5 times 0.45. Put in the calculator, you get 2.025. And for the similar light bulb, this is 2.025. Hey, also, power going in equals power coming out. So if I add up these two, they equal the power. So I must be doing something right. Good. Hey, for the voltage graph, I've already labeled these positions across the horizontal axis, and we have to go up to 9 volts. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. That seems like a good value there. 9, we'll start at 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 volts. Hey, so let's start around this circuit. So starting here, we're at 0 volts. At position 1, I went up 9 volts. So I'll go from here to here, so 9 volts. And I stay at that voltage at positions 1, 2, 3, and 4. So all the way over to position 4. 1, 2, 3, 4. So my battery raises my voltage and stays constant across those resistors. Okay, sorry, across the wires. My voltage drop from 4 to 5 is 4.5 volts. So from 9 minus 4.5, I get 4.5. Is it right about here? So I drop 4.5 volts. From 5 to 6, the same voltage. And then from 6 to 7, I drop another 4.5 volts. And then I'm at 0 volts all the way to the end. And maybe just put a note here. That's at 4.5 volts. Okay. Hey, does that satisfy one of Kirchhoff's laws that the voltage raised from 0 to 9 volts equals the voltage drop from 9 back down to 0? Yeah. So we should find that the value here and the value at the end are going to be the same. Last instruction, let's go and put in some values at each of these. And we can just follow off the graph. 0, 1. Now I have, I might just write, let's see, can I get write it here? 9. 9. Hope you can follow this. Sorry about it. It's red on a red writing on a red background. This one I dropped 9, 4.5 volts, so I'm at 4.5 volts. 4.5 volts. 4.5 minus the 4.5 drop, so I'm at 0, 0, 0. You can see that's labeled at 0. Right, so that's how you end up doing one of these graphs. Hey, we could even put this value in here. My resistance equal to 10 ohms, and resistor 2 is equal to 10 ohms. Okay, so for now, that's series circuits.